this is the final version. These are the secondary beams, and here are the primary beams, and here are the columns. Here it is. So this is the main structure. Let's go now to the floors. You see that we still miss the floors here. We only have the structural elements right now. So let's go down to the floor and let's build actually with the new material layer definition that we have available. So let's build these floors properly. Let me move all of these things a little backward, but let me delete everything. Let's build from scratch. Also, there's some air here, which is eventually a nonsense. And let's also sort these things with the proper order. Eventually, I will change this in something like the substrate or something like that. So this is going to be the structural part. This is going to be the finish part. So let's put the structural part here. Finish part is going to stay up here. And also we will create a second finish layer right below the floor. So starting from top, remember that in the order in which you must connect things inside the Revit floor type is from top to bottom. So nice tiles is actually going to be something like remember to use here a value list in order to give the proper name. I only remember in this moment that ceramic tile and not tiles is the material already present in Revit library. No need to define other things, but class. So class is going to be ceramic. This is important also for defining the material category, but probably, or sorry, not problem, mainly if you are creating some kind of custom material. But if you refer to an existing material, everything should be derived by the material library in Revit, including all the properties and everything. Nevertheless, try to keep things consistent, like defining the proper material class according to the material name that you are defining. So Revit material is going to be this one. Thickness, 2 centimeters looks pretty good. Function is going to be finish. Does it belong to the core? I would say no. And is it structural? No, as well. So this is pretty it for defining the material layer. So yeah, I think we can move on to the substrate. So another instance, this of course is going to be, maybe we can refer to a real material here. I think there are some, yeah, concrete lightweight, for example. We can use this. Remember, well, it's not enough to say concrete lightweight, it's concrete, comma, lightweight. So just, that's why I say you better build a consistent value list in Grasshopper in order to avoid having to go back and forth from Revit, you know. So change this to this name, so Revit is going to recognize this material. So the class is going to be concrete. This is going to be Revit material, and the thickness eventually, well, 4.5 centimeters. It's ridiculous. I would say, well, no, it's not ridiculous. Let's keep this 5 centimeters of this light concrete. As thickness, function is going to be a substrate, and is it part of the core? Well, technically yes, but if you want, you can also use the core in order to, in Revit, in order to let's say create a custom structure for the floor for several purposes. So the way you define the core has several consequences in Revit. Probably from the architectural point of view, the most relevant is the way that finishes and core layers are connected. For example, when you connect a floor with a wall, the layers behave automatically according to whether they belong to the core or not. So there are several considerations that you should do eventually for this, but um, in general, you could say, like a general simplification, you could say that what's outside from the core normally is used by Revit to create some connections between finishes, for example, and what's inside the core is used to create some, let's call them structural connection. Okay, so this is in general. But anyway, I'm going to define these as outside from the core, outside from the core, just to have a let's say visual correspondence between what we are doing here and in Revit in order to find these changes in Revit. And is this structural? No, it is not structural. Okay. So another way is to place all the structural things inside the core, for example. Okay, so this is the concrete lightweight, and the um, uh, what is it? The function is, oh, well, I already set it to substrate. Then I would create the structural part. So let's add another layer to this floor. Let's move all of these things down here. Let's create another layer, which is going to be somehow similar to this. And we are going to use, in this case, another concrete can be cast in place, for example. So just to change this type momentarily, but I'm not going to save the changes here in Revit template. It's just to copy paste the name, basically. So go here, change this to the right name material. The class is once again concrete, so no problem with that. Let's grab another instance of GG Revit material layer and material. Thickness, probably this is the structural part, so we must give proper thickness to this, just in order to round up things. Well, even if it's not necessary, because I'm already automated here the name of the floor that we are creating, so there is no particular need to pay attention to the thicknesses that we are going to use. This is just something that here I try to do, is to derive the name of this floor type from the thickness, the global thickness of the floor itself. So you will see this in a while. So let's give this a thickness of 20 centimeters, the structural part. So the function is going to be, in this case, structure. By default, you see everything in Geometry G is by default structural. Is it part of the core? In this case, yes, it's part of the core. Is it structural? Yes, it is structural. So another material layer. This is going to be something like there was something for ceilings. Yes, there is a ceilings material here. There is ceiling tile, for example, ceiling tile. Let's give this a twist like a office space. Ceiling tile 600 by 600. Cancel this. I no longer need it. So this is going to be the material. And class, actually, well, I'm not sure here what's the best option. Probably a simple generic would work. There is no actually a specific class for this kind of material here. So this is going to be the Revit material. The thickness probably going to be something like, I don't know, here it depends on many things. You could also include some layer, for example, if you want some installations to pass through the ceiling and so on, eventually leave like air in that case, but we are going to like glue the this ceiling to the structural element. So let's give this just 5 centimeters thickness. This is already affecting something like here, as you can see, but we will discuss this in a while. So the function is going to be finish. And is it part of the core? No. Is this structural? No. So yeah, that's pretty it. So we have finally a proper definition of material layers, whether they are inside or outside from the core. So these are already set to be connected to the layers input. But here there is a small group of components that I am using to create the name for this floor. So you see, in this case, for example, the name is going to be generic 120 millimeters, because it is basically creating an addition of all the thicknesses. Well, not all the thicknesses, because we miss one here, but all the thicknesses for the material layer. So we have 4 layers. We must add an input to this addition component, and we just plug all the thicknesses that we are using to these inputs. And even if we are working in meters, you might have noticed from Revit that when you have some floors, they are defined like in millimeters. So that's why I was converting here. I was simply doing a multiplication by 1000 in order to switch from meters to millimeters. So the result is going to be 320 millimeters, 32 centimeters. This misalignment that you see here is because we did not plug the material layers to the floor type. And so from top to bottom, first layer, we can also, and these are the structural beams, so we are not actually seeing the floors. These are the floors. So let's connect all these layers: substrate, structural part, which is going to be the thicker layer, and finally the lower finish. Here it is. So yes, we have everything should be set properly in this moment. Later, when we are going to import things in Revit, we will double check that the structure for this floor is transferred properly. Remember also that these floors are actually passed to the void component created the shaft for the step. That's why we already see these holes here. So let me group this back together. No, sorry, like positive selection. Okay. Yeah, everything is set. And first, let's concentrate on things that we are going to export to Revit, and then we eventually will take a look at those things that are not going to be used. So as regards the stairs, there is another element here on top, which are these fancy railings that I was creating just to play around with additional geometry. It depends on how much patience you have and also on how much time you have to define things properly. This is just for teaching purposes, so I didn't spend too much time in defining railing like more properly. Eventually, you see they work basically, but they are missing some elements. Like for example, these horizontal elements are just ending up like this. There is no connection, no vertical connection, so it's very unlikely that they can stay like this. While the vertical elements are, well, they work well, so they connect each step with the correspondent ceiling, so they work pretty well. Railings. So in this case, we are talking about railings, and it's everything up here at the top of the stair definition. Once again, defined at the ground level, and then eventually repeated vertically. There are two, let's say, two types or two elements for this railing: the vertical elements and the horizontal level, the horizontal elements. Once again, there is a reason why I did this like separately, and I'm going to tell you in a while. So this offset curve, once again, these are the side lines, but the side lines like splitted by steps. So if I take this midpoint, I have the midpoint of the side of each step. And this is for positioning the vertical elements like at half the depth of one step. some simple vertical displacement to align this point exactly with the height of the step they are connected to. Then there is a small, sorry, there is also a small side displacement that I don't remember actually if it was here or something like, yeah, it's this. You see that this is actually also moving the point a little aside, not coincident with the side of sideline for the step. It's just a little aside. I didn't create here the connection with the step, but it's just geometry. You can do this easily. Okay. Um, then there is this projection that are actually taking the points and projecting them both on the upper frame, which is basically the ceiling, and also the vertical frame at the end of the step. And I am using this to create the vertical and horizontal connection. See? And in the end, I'm creating an array of the horizontal elements, but you see that we don't need these horizontal elements here at the ground floor because we have no holes in the floor. So that's why I call index eliminated the first branch of this data tree, but the first instance of the array, basically, not the first branch of the data tree. So I left only the upper levels as regards the horizontal railings. As the vertical railings are necessary at all these levels, then you simply take the array. In this case, the array works pretty nice. So there is no need to create different things. And this is a join curve. You see that I have joined the vertical element with the horizontal element, of course, where you have horizontal elements as well. And where you don't have this, you will have just vertical lines. So curves, as a result, you have polylines, but also lines. Okay. And then I piped this. I'm not a huge fan of the pipe command, but because it produces a very heavy geometry. So eventually, if you display a canvas widget like the profiler, you will see that this is one of the slowest component that you have in your definition. So this is 170 milliseconds, which looks quite fast, but you have to think that this is actually occupying this time for every cycle of your processor. And then architectural direct shape once again, because there is no railing element. Okay, so if you don't find Revit element like here directly, then you must define an architectural direct shape. Now there are also some tweakings that you can eventually do. You will see we will see this later on in the third exercise that we have eventually tomorrow, probably. I don't know. Which is the twisted tower that I already prepared. So we will be discussing these architectural direct shape things more in detail eventually later with another example. But yes, basically that's pretty it. So these are the railings that we want to use we want to transfer to Revit. So I think everything is consistent right now. Let's have a look from the top viewport. Let me turn off these points. So yeah, we eliminated these secondary beams, and the orientation is properly set. So yeah, it's working pretty well. Let me also turn off the secondary beam points for the orientation. Of course, in any moment, for example, you can also tweak these things. You see. You see that, for example, I would also change the orientation of these in order to have a more symmetrical distribution of orientation. In this case, it's pretty simple. Set multiple points. You just pick. It doesn't like put the point exactly in the center. I mean, it just point in region actually. So it's just clicking inside the proper region, and you're set. Okay, so don't waste too much time with this method. So yeah, maybe this orientation looks nicer than previous one, and also it's a little more symmetrical. So should avoid some kind of asymmetrical behavior for this structure. But anyway, let's concentrate on the architectural part. So we have railings, voids or shaft. We have the stairs. We have primary and secondary beams. We have columns. We have floors with openings. Perfect. And what's here at the bottom and here on the right. These are some additional elements that I have created. Just well, the first one that we're going to see is this one, which are basically walls with hosted elements, which, as you can imagine, are doors and windows. Okay. And while here we have a roof or something like a roof for our building, so something to close and cover the upper floor. So let's start with the walls. Okay. Walls are defined, once again, you have instance and type. Walls are defined by path or perimeter. Now, this is something that it is not necessarily so. We are going to discuss this in a moment, but there are some limitations for the definition of this wall. And so, for example, what I did here was take the vertical axis of the lines of the beams. No, sorry, I think I took actually the points. Yeah, it's actually the same, but I just need a line on the floor corresponded to the axis of the columns. As I'm creating a bounding box here below, if I take the vertical axis, I will have a box with a height. Okay, but if I take only the points lying at the ground floor, the bounding box would be a flat box. So let me hide these things. So this is going to be a flat box, you see. Just pay attention that it must be a union box, because as you would be creating a bounding box for each point individually. If you switch to union box, you will be creating this kind of flat box here. So having a flat box, it's nice because we already know what's the silhouette that contains all the column axes. So I grab a B-rep wireframe. So this is actually the edges of the flat box. So it's basically a rectangle right now. Join the wireframe, obtain exactly the rectangle, and offset this outward with a specific offset distance. Now, this is up to you. I just created an offset wide enough to include the column thickness and also to leave some distance, some separation between the column and the outer profile of the floor. Okay. So you see also there are some components that are not exactly buggy in Grasshopper, but you see this frame here. This frame belongs to this offset. Okay, and so if you turn off the preview of this, you see that the frame is still visible. And now there are other offsets here. So this frame could also belong to other things. I personally don't like these frames showing up. So you should detect to which component this frame belongs in order to do something. And that something is normally, I do this by extracting the parameter, which is the frame, and turning the preview off. This will automatically leave you with the offset, only with the geometric interesting result and not with the frame visualization. But anyway, this is just personal OCD. So this is actually going to be the outer profile for our wall. Okay, so I took this, exploded this into lines, created a vertical array in order to have these 4 lines all around the building. This is just a let's say pass-through component. It's not necessary. You can also switch all this cable, displace all this cable to the actual geometry output. It's not mandatory to have this. I normally do this just for avoiding wires passing through other components. You can also do this with a different technique, which is double-clicking on the wire. You have this relay, and from this you can, let's say, pull out several wires. Okay, so this is something that avoids creating this kind of connection component. And these lines are going to be used as the path. Now, if I turn on the preview of this, you see that I not only have the linear walls already visible, I also have windows. Now, this is another situation in which what happens next affects what comes first. You know, it's something like counterintuitive for Grasshopper users, but this is how this thing works, because once you have defined the wall, because we have hosted elements, so a window, if you go inside Revit, and I go inside, for example, level 2 viewport, there is no wall here. There are only floors and stairs, okay? So if I try to place a window, Revit says, okay, you cannot place any window because you don't have the host. Click on wall to place window, okay? So if you don't have any wall, you cannot place any window because the window is the so-called hosted element, like the door also. So if you don't have the host, you cannot place neither the door nor the window. So here comes the wall creation, which is the host, and now you can place the hosted element like windows and doors. Let's concentrate on windows. The presence of the window is actually represented by this rectangle. So in Grasshopper, you don't get any 3D window, basically. You just get the hole. So the important thing is to define the geometrical aspect of the window, which means the width and height, and the family type. If you define the family type properly, once you import in Revit, you will have the family automatically recognized, and you will see the 3D elements occupying the space, the void that is being created inside here in Grasshopper. And this hole, even if it's created after the host, which is the wall, is actually affecting the wall with this three-dimensional hole. It's like the shaft for the stairs and the floor. In this case, the window is like a shaft for the wall. Okay. So there is no particular need of leaving the preview of this element on. That's why it was off. Not deactivated. If you deactivate this, the window will not be exported to Revit. Okay, so leave it active, but you can simply hide the preview if you don't want to see these rectangles. How does this thing work? Well, in general, it works exactly the same. So you have the Revit Windows instance and type. Okay, so it's you already know how this general workflow is created. This is the family name, grid window. Of course, it is just fancy name in this case, and width and height. So you have here you have defined the window family and also the parameters in terms of window width and height. Now, positioning the window, it's a little tricky, especially if you pretend to do this once for all the walls. Okay, because it is done parametrically. So how does it work? Well, here we have the extrusion of the perimeter of these walls. Let me hide the three-dimensional objects, okay? So these are just vertical extrusion, flat surfaces, no thickness here, okay? And then there is the evaluate surface. Evaluate surface is actually using a two-dimensional coordinate system, which is called UV. That's why here I hit the reparameterize button, so I can work with parametric coordinates, which are internal coordinates to these surfaces. Remember that we are extruding 12 lines, 4 lines per level. So these are separated, so independent surfaces. We have 4 independent surfaces per level. And so we are reparameterizing each of these flat panel here. Okay, so they are rectangular surfaces. We are reparameterizing them, which means that for Grasshopper, in this moment, they measure 1 by 1, independently from the geometrical aspect. And we use this slider here to say, okay, I want to place the window. Let's activate this. I want to place the window using this parameter here. So as these are extrusions, right, pay attention to these. As these are extrusion, and an extrusion is created extruding a profile, which is an horizontal profile actually, in this direction. This direction is going to be the U direction, while the direction, the orientation of the profile is going to be the V direction. So what I'm telling right now is that I want the window to have its lower left corner, which is this point here, at 0.21 u, which means along this direction. If this is 1, this point here, oh, sorry, this point here is actually located at 0.1 parametrically, so 1/5 of the global height. While this says we are more or less at the center of the horizontal aspect, the horizontal dimension of this wall. So this is how you place a window along a surface. Okay, and we are doing this like equally for all the elements. Okay. Now, sometimes you might notice that the frame or the rectangle shows up in a weird way. Like, for example, here and here. You see? Uh, this it's something that bothers me somehow, but the important thing is that as a result, you don't have any error. See, so everything is consistent. So for some strange reason, the preview is not aligned. It's not in line with the final result. But never mind. Just keep in mind that this can happen. You see, but the final result is still displayed and working properly, both in Rhino, Grasshopper, and in Revit as well. Okay, and of course, once you define this frame, what I did here was actually, oh, I think this is actually one of the problem. I just, as it says, just give me the location, and the location is a frame, as you can see. The important thing here is just the alignment. Okay, so if we consider this evaluate surface here, let me switch to wireframe. Eventually, it becomes a little more clear. Let me also hide some things like the primary and secondary beams. So you see that, for example, these frames here, due to the fact that these are extruded surfaces, the x-axis is oriented upward, while the y-axis is oriented horizontally. Now, we are defining a window, so the width of the window should correspond to the horizontal dimension. But if we have the frame oriented like this, then our window will be rotated 90 degrees. So that's why I have deconstructed the plane in order to have access to its X, Y, and Z axis, and built another construction plane using the origin as origin and the y-axis as x-axis. So the y-axis is going to be the x-axis for our new frame. And in order to have things defined properly, it should also define the y-axis, which is going to be, if you see here, the vertical is going to be the y-axis. It's always the x-axis for the actual evaluate surface. And so you can plug the x-axis to the y-axis. And now we have the frames oriented properly, okay, without any inclination or weird behavior. But nevertheless, the more important thing here is the origin of the plane, because you see that now we have this kind of things. So we are defining the horizontal the horizontal frame, because the windows in Revit also have depth. Even if we only see a rectangle here, consider that in Revit the depth is defined by the wall, so they are hosted elements, and so that's why you have this kind of representation. But nevertheless, if you want, you can align this plane easily with the wall if you want. The important thing is the orientation, okay? Not the position and orientation, not exactly the orientation of the frame. So yeah, that's it. We have placed the window. We can do this, for example, for the whole building in case you have this alignment, which is something quite usual. But for example, this is something that with the door is not going to work exactly the same, because if I activate this, you see that there are some doors around this building. You see that the wall is not actually displaying anything. If I try to refresh, you see what I did here was hitting F5. So recompute the solution, then this wall, as the wall comes before the hosted element, if I reactivate this and the wall doesn't depend on its output, the wall is not receiving this thing in real time. So you must refresh the solution. And in this moment, you see that we already have the doors displayed. Now, of course, it makes sense to have a door at the ground floor, for example. It makes less sense to have a door here and here, unless you have some terrace or balconies or whatever, right? So we must also think about this aspect. Nevertheless, if you want to avoid doing some hard work in Grasshopper, like isolating the walls from the ground floor with respect to the walls from the upper floors, and then deciding the position for the door at that specific floor without affecting the upper floor, well, you can do this. But the other thing that you can do is just place the door wherever. And once you are in Revit, just delete the doors that you don't need. Of course, if you have a huge building and you have hundreds of doors, then in that case, it might be like a problem. But for example, one thing that you can do, this is just modeling strategies, of course. Let's say that you are creating a door that you already know that is going to disappear at the higher floors, okay? And you don't want to waste time like isolating the right floor from the floors that you want to leave out from the process. So what you can do, for example, is something like this. There is a problem actually with with the door families. Actually, door families are not recognized by Revit. So you will see that if you don't provide the right name, um, if you don't provide the right name to this family, Revit will create just a void inside the wall. So what you see here is what you will get in Revit. But if this family name already exists in your Revit file, so either is part of the template or is a family type that it's already loaded in your project, then you will see not only the void, but also the corresponding architectural element present in this frame here. In this case, this automatic recognition is not working. So John is already looking at this because it's an important feature. It works for all the other elements, but not for these hosted elements. So something that is going to be solved soon. Anyway, what I'm going to do here, I'm going to name this like ground floor door, right? Something like this. So I am defining a specific door family or door type that I can also find the correspondence in Revit. I mean, this is not the way you must work. This is a trick that you can, let's say, implement in order to ease the process of deleting things in Revit once you have them. Thinking about hundreds of doors, for example. So if you define this as ground floor door, for example, and you export it, you will have this element, these voids, and the corresponding door placed with corresponds to any void, to each void at each level. But once you are in Revit, you can select the element by type and by layer, by level. So you can select all the doors that must only appear on the ground floor and get rid of them level by level, selecting with one click all the instances of that type of door. So with one delete operation, you are going to delete all the doors that are not necessary at the correspondent level. Okay, so this is something like a trick for bypassing this kind of thing, unless you want to work parametrically here in Grasshopper, or you have the need to work parametrically here in Grasshopper. Also, another thing that we can do here, for example, is that the placing the door happens more or less exactly like the frame, but it refers to you can refer to the original line that we have extruded to create the wall. So basically the wall axis, okay? So I took the wall axis, reparameterized this curve, and created a not normalized slider from between 0 and 1 to place this at more or less 1/5 of the extension of the wall. Once you have this point, you use it as the origin, and the tangent to the line is going to be the x-axis. So we get these frames here, and we use them as location. You must provide, of course, for this hosted element, you must provide the Revit wall. Okay. So Revit wall here is 12 elements. Location is 12 elements as well. And you see that there is a null plane. Now, why is this happening? Because we are not defining the y-axis. Okay, so if you want to be more precise, you see that the plane is not mandatory to define it properly, because even if there are three frames that are not defined properly, as you can see, we miss these 3 frames here. Okay, they are present in all the 3 facades, but this one. Nevertheless, Revit is, well, actually, Grasshopper is capable of placing this door properly, because it takes the natural orientation of the wall axis. The first point, the origin point, is correctly defined. Okay, it only misses the orientation of the frame, but this is not mandatory. Okay? You can also work with the point as the location. Okay. There are not so many ways of orienting a door inside a wall. Okay, so it's just either one side or the other side of the origin point. In this case, it flows with the natural orientation of the wall axis. Okay. So yes, that's pretty it with this. And yeah, this is our attempts to make to force Revit to recognize the family type, but this is something that we cannot solve at the moment because it depends on the plugin itself. And so we have the walls as well, and we have the windows that are already defined. And let's take a look at, well, no, let's leave the roof like something that eventually we will double check, but it's no rocket science. There are 2 trusses and a direct shape for defining the curved roof because it is curved, but we will take a look at this later on eventually. So what I'm going to do right now, first of all, just for avoiding any type of solution problem, let's refresh the definition with F5. And you say it took some times, like 3 seconds, because it's quite complex, quite rich of elements. The fact that these components here, like the primary and secondary beams, are switched off in terms of preview, doesn't affect the export process. So unless you deactivate one of these, so if you Control E, for example, this will not be exported. Okay. But if it's active, even if its preview is turned off, it will be exported as well. So we want to export all of these things to Revit. Let me double check. We have everything here. So we have primary beam, secondary beam, railing, stairs, floors also. Yes, floors, walls, columns. Yeah. So, and grids, of course, grid lines. So yes, I think we don't have to activate anything else. So in this case, for example, the preview is turned off because I don't want to see the rectangles, but nevertheless, this is already affecting the wall. And then we go and find our bake to file button. Once again, it's easy to find it in my definitions because it's grouped along with this round button here, as we saw yesterday. So save this, and we double click on this. We are going to create the export in our folder. This is going to be today multi-story building. And it's done. It's pretty fast because it's actually writing a text file. There is no, let's say, particular thing to discuss. Actually, you can take the IFC, which is this one, and eventually you can edit with some editor, whatever editor you might want to use. So you see what's the content of this IFC file. If you get used enough, or you know a little more about this conversion. You see that I already opened many of them. Also because I was double checking the content with Geometry Gym. If you get a little used to this, you can also recognize things inside this IFC. So for example, I was having a problem with the file unit, and you see that now, for example, here you can easily find the meter and square meter and cubic meter, which are the default units. This means that in Revit you must have the proper unit system already set, because else you will have a scale problem. This is very common for those who try to import things in Revit from other software, not necessarily Rhino Grasshopper. So here, for example, I was double checking that the unit was set up properly, okay, and other things. But this is simply a TXT file or a text file actually. So you can scroll down and see all the elements and all the aspect of the elements. It's like in the Matrix movie. You see the code actually. So let's switch to Revit. Let's also close this dummy project here. No, I don't want to save it. Let's create a new one. Of course, I already have some import already done. We will see them. If something goes wrong with the import process, we'll eventually switch to an existing file. So create a new project. You see that I switched from the standard architectural template to a different one. So let's see why. If I open the template file with an architectural template, and I go, for example, in the manage project units, you see that this is set to work with millimeters as length. And I don't want this, because if I do this, once I import the IFC file, I will see nothing, because the IFC file will measure something like, let's see here, the width of this building is more or less 15 meters. Okay, so if I import this inside a Revit project set to work in millimeters, I will have a building of basically 1.5 centimeters, which is going to be somewhere in this area, extremely small. And so this is something very common. It happens often with Revit users that try to import things without paying attention to the units. So nothing appears. So normally the users tend to repeat the operation like thinking, I don't see the result. If I do it again, maybe it will show up. But no. So the problem is with the scale. Okay, so if you see this behavior, it's because you didn't set the units properly. So in my custom template, I just changed the units that you just saw into meters. Okay, so if I create a new template and go back in manage and project units, you see that this is set to work in meters. Okay? And this is very simple. When you create your template, you just go into manage project units, you click on this, and you define what unit you want to use, with how many decimal places, if you want to use a unit simple, if you want to suppress trailing zeros, and so on. Okay. And as this property, you must set up almost everything in your Revit template file. So this is a big manager work. Or eventually, there are also other figures that are actually present in an architectural engineering firm, which are the template master, I would say. So there is one person that works on the template, and there must be no other person with the right to edit these template files. So this is quite normal in a BIM optimized environment. So we have this blank file, and we are going to go into Geometry Gym. Here is where you find the import plugin from Geometry Gym. Import IFC, select the IFC, which is today's IFC. Now this is going to be a little slower because of the amount of beams that we have, but just let's have a little patience right now. And let's wait for this to complete. Eventually, some warning will come out because of the door and window families that eventually are not going to be recognized by Revit. But this is just like hitting a OK button and be aware that this thing has happened. So let's wait a little and let's wait for this to finish. Yes. Okay, you see that M underscore single dash flush not found loaded in Revit project. Now that's the problem I was telling you. I'm going to show you one thing in a few seconds when this ends the import process. So I think it's done. Yeah, you see that you can already select things. Now I want to switch to architecture and take the door and look at this. M underscore single dash flush. So it is present, it is loaded inside the Revit file, but nevertheless, it is actually not being recognized by Revit when you import it via geometry tools. Okay, so it's already present, but it is not working. But anyway, all the rest of the elements has been imported properly. You see that there was no warning, no error, so it's pretty smooth as a workflow. See, there is absolutely no problem. Take a look at this. Look at this pattern here. This pattern belongs to the ceramic tile that we have defined in Grasshopper. Now, if I select this floor, is generic 320 millimeters, like we have defined in Grasshopper. So let's go back to our floor. The name is this one, generic 320 millimeters. Okay, and the upper layer was ceramic tile. Now, if we go here and edit type, you will see that there is also this preview of the elements. So we have the upper finish, substrate, structure, and lower finish. Default thickness is basically given by the addition of all the structural layers that we have here. And you see that because we have used Revit material that are being recognized during the import process, we also have heat transfer, thermal resistance, thermal mass, absorption, and so on. So all the physical parameters that affect the, for example, energy efficiency analysis and so on. Okay. So you see that we are importing not only the geometry for this floor, but also the actual structure and the actual physical properties. Even if we didn't define all these properties at the floor type level or at the material level, because we are using a material that already exists in Revit library, all the properties are being transferred by the library to this particular architectural element. Okay, and if we go inside the structure now, you see that the only layer belonging to the core is actually the structure, which is, by the way, concrete cast in place gray with 20 centimeters thickness. Okay. So total thickness is this value. This is the value that is going to be used as the default thickness or the global thickness for our floor. So everything is basically working properly. The only structural material is the structure, the concrete cast in place from the core layer. Okay. If you want, of course, you can change things inside here. Remember that if you do this, you are working at the type level. So if you make some changes here inside, you are going to affect all the floors sharing the same type. Okay, just so that it's clear. We are not working on an instance, you are working on a type because we pressed the edit type button here. So don't change things inside here if you don't want to affect the whole project. And here inside, for example, if we go into finish one ceramic tile and take a look at the material, you see that the surface pattern is this square here. That's why in the floor plan you see the floor represented with this square-ish pattern here. That eventually you can change. There is also a shaded color, which is this kind of light coto color, like sand, which is will be affecting the visualization of this particular floor plan if you switch from hidden line, which is the default, to shaded. So you see that it takes this pinkish or sand color. This belongs to the property of the material, which is properly recognized by Revit. Um, so yeah, everything is working properly. You see the grid axis. Uh, you see that they are already connected together as regard the extension because they are basically the same length from Grasshopper. So both the direction for these grid lines are already connected. So the problem that Soto was pointing out at the beginning of this of today's section, if we go to the, I don't know, south elevation view, okay, you see that there are two blue level and two black level. Now, the blue levels were already present in Revit template. Level 1 and level 2 already belong to the template. Okay, so that's why they already have the corresponding floor plan associated, level 1 and level 2. So that's why you have this blue symbol. These are the imported symbols, the imported level, the new levels. Um, they are black because Revit is receiving this input from the outside, and well, it was not created inside Revit, so there is no automatic connection with the floor plans. So first thing that you might want to do when you import something from Rhino to Grasshopper, in order to keep things neat and organized, is to align levels, because this is something that visually helps a lot. Okay, so you see that they must be aligned in both extension, and therefore you can now move them all together. See, also the section, they are not defined vertically, so there is an attempt to cover the project, but this is only referring to the first two floors, which were already present. Even if we have changed the height, remember that during the IFC import there is something like adjust existing level height. You know, so level 1 was initially this one, and level 2 was initially this one. That's why the vertical grid line are only covering the first two layers of our building. Okay, but nevertheless, you can still edit things and adjust the grid lines properly. So these are the standard operation that you might want to do when you first import something from Rhino to Revit. Then let's take care of the black levels. So the levels that don't have the corresponding floor plans. First of all, if you don't need the correspondent floor plans, there is no need to create the floor plan, for example, for level 3, or if you have a tower where the floors are always the same, well, basically there is no need to create the floor plans, unless you are going to work with schedules, quantities, and so on, of course. But if it's just for representation and drawings, then in that case you can also skip this part here. But anyway, if you want to have the corresponding floor plans, then you go into view and you create plan views, floor plan. Okay, you create this and you're asked for what existing levels not connected already to a floor plan you want to use to create the new floor plans. And you only have the options of level 0 and level 3. You can select either one of the two or all the existing levels. Do not duplicate existing views. Okay, if you deactivate this, you are also allowed to duplicate the floor plans from level 1 to level 2. This might look like a nonsense, but it makes perfect sense. Just we are not going to discuss this today. And therefore, you also have now level 0 and level 3. Let's close these. Let's go to level 0. This is actually level 0 floor plan. Okay. So that's how, and if you go back, you know that now south has all the blue symbols for the levels because everyone has its own corresponding floor plan. Let's go to level 1, and let's create, for example, the cross section in order to double check what happened with these stairs here. We are at level 1. You see, the fact that being at level 1, we should see just a portion of the stair. You see, this is a section happening at a certain height because there is this ramp going up, but this is the lower ramp coming from downstairs and reaching the level 1 height. So the fact that we can see this means that the shaft is already being placed inside this model, and it has been properly recognized. So you see that if you hover with the mouse here, this is the stair element, but if you hover with the mouse here, this is the shaft openings. So there is this box here, which is visible in 3D. You see this is generating the openings, and this is actually starting from level 0 with 0 offset, reaching up to level 3 with 0 offset. So it's covering from, it's basically cutting this floor, and this floor. If you don't want to cut the roof, even if you have a stair, you just stop at level 2, or say you want to reach level 3 with an offset of minus something in order to avoid cutting this floor. That's how this thing works. Also, talking about aligning the symbols, for example, you see that these level symbols are not aligned. They have this kind of curved aspect. This means that if now we are in 3D, this is front, right, top. So if we go into the south elevation or east elevation, yeah, you see that the levels are not aligned in this viewport. So it's worth spending some time to adjust these things, because this will be something that you will have already set when you will create, for example, presentation sheets or whatever. And in this case, for example, you see that they are not connected. So you connect and then drag in order to affect all the levels. And also in this case, you might want to drag this to connect it with the remaining levels. And that's it. And you do this for all your views. So once you see that things are working properly, then you are done. And also this means that if we go back to our 3D view, you see that now everything is aligned. Okay? So this is a visual check that things are aligned in your elevation views. Now we have all the viewports. Let's go back to level 0. Let's create our, well, level 1 eventually, so we can see all the stair. And let's create a cross section, so we can also double check what happens with this element. And let's go here, and here's what we have. So we have this cross section is actually at the worst quality of representation. This rectangle that I am changing is actually the extension of the cross section. Okay, so you notice that if we go back here, you see that this is the cross section line, which is the symbol that you will have visible in your floor plan, for example. And if you select this, you will see that there is also this dashed line, which refer to the actual visualization that you get inside your section view. So once you create the section, an additional group of viewports is added, which is sections, and you go here and you have this section. So what I was tweaking here was exactly that rectangle, that dashed rectangle, in order to include also the level symbol and the grid line symbols. So this is the worst representation possible. If you go down here, besides selecting the scale of representation, you can select the level of detail. Now it's set to coarse, which is the lightest visualization possible, but you miss lots of details, of course. So if I move closer, for example, to this area where I have the roof, I don't see the detail of the layers, which we created in Grasshopper. But if I switch to, for example, fine, I see the details from the beams, the details from the small beams, the details from the layers of this floor, and also the hatches that are by default associated to the material. Okay, so everything is showing up correctly. Remember that there are some problems that cannot be solved automatically in Revit, but you understand that this is absolutely a minimal amount of work with respect to creating this kind of drawing. Okay. Also, in this case, you might want to double check that the finishes here are defined properly, because basically you are leaving the structural layers, substrate, and so on exposed on this side. But this is some details that you can add easily by working with CAD software. So railings are being imported, and you see that all the details are in place. You can switch to, for example, a shaded view. So you can have a shaded visualization of this thing. You can go back and visualize also the thick lines. So you have an idea of the cross section of the section element with respect to the visible element. And so it starts to take an interesting aspect to this viewport. And you can also work with shadows and so on if you want to take into account the illumination that you get. Normally, shadows here, for example, are 45 degrees by default. And I think it's important to observe this kind of behavior, even if it's more from Revit than Grasshopper to Revit. But it's as it's very easy to get to this point. Maybe it's worth focusing on these automatic things. But these are 45 degrees shadows, but you can set up the sun settings according to whatever type of a particular light condition you might want to use. And you see that you have the default top right and top left, which are 45 from right or left. Okay. One thing that I would recommend is that you set up the ground plane at the proper level that you might want to use for the shadow representation. Okay. It's level 1 because originally, remember that level 1 was the ground floor for Revit. That's why it's set to level 1. In a normal Revit workflow, it is set to level 1, but level 1 is ground floor. So you must change everything if you import this from Rhino, unless in Rhino you decide that your where are the floors? The floor are here. Unless you decide in Rhino that the level, not the floor, the levels. You decide that the start number for this series is 1 instead of 0. So if you do this, you will have an automatic recognition. This will be level 1, 2, 3, and 4, and so on. I don't know why, but normally I prefer to work with level 0 as the ground floor. So first floor is level 1, second floor is level 2, and so on. But this is up to you. Okay. Also, it's important to notice that if we go, for example, to levels, level 0 or level 1, whatever, it doesn't matter. Okay, you can do the same tweaking for the view also in the floor plans. So you can also change, for example, to fine detail, where you will have all this. The wall, for example. If we go back to Grasshopper and take a look at the wall has been defined as a wall with two simple layers. Also, it is not defined with the new material. So what happened here in Revit? If I select this wall, oh, by the way, Pepe, see that the connection between this wall and this one is taken care automatically by Revit. Okay. And also, if we go into the section view, you will see that in this case, for example, there is no connection because of how the floor is reaching. Well, actually, it is not aligned with the wall. But if you align things, then you will have the finished layers, for example, turning around these corners. So yeah, connections are automatically created during this export-import process. Let's go back to our level 0. Let's select this wall. Let's go into edit type, and you will see that there is just 2 layers, some concrete and some plaster here. Okay. And as regard the structure, because we were using the old material layer definition, everything is inside the core boundary. But we can easily tweak this thing right now. We know how to do this. Eventually, I will do this in a while. So you can change things basically as we already saw. We can switch to a shaded view, the desired amount, level of detail. You can also change the scale. Now, if you change the scale, you must also, well, normally level of detail and scale, they more or less work together, or at least you should tweak these 2 things together. Because if you switch, for example, to, I don't know, 1 to 20, you will have a final representation of all the details, which means, by the way, that also the label and tags are going to look smaller. By the way, let's go back to 1 to 100, okay? You could also turn on shadows, for example. Remember that in this case, it's good to have level 1 as the ground level, because I'm just taking a look at level 1, and I want the shadow to be referred to level 1. Okay, so you see all the shadows from the stair, the chunk of column that is not cut, so everything is set up properly. We miss the windows and the doors because Revit didn't recognize, not even the doors. Okay, and when it doesn't recognize the doors during the IFC import, it only leaves the voids, which is already something. Okay, um, so if you don't want doors at this upper level, like for example this one, just select and delete it. If you select this door and right click, you can also select all instances visible in view. So you select, that's what I was saying. You can select all the instances of this thing and delete them at once. So it's very easy. Also, if you have hundreds of doors, like the same type, you can select all the instances of that type and then delete all the doors automatically. So you can easily do this at each level, like select all instances visible in view, not in the project, because else you will also delete the doors at level 0, which you want to maintain eventually. And here, level 3, you don't have any walls because we already reached the roof. Okay, and so we got rid of all the upper doors, and we left the lower doors on the ground. Um, One other thing that I wanted to show you, well, let's turn off the shadow because somehow uh, not that relevant. Of course, once you have these voids here, which is called grid window because this is the name of the family that we were using, you can also select, for example, all instances of this thing in the entire project, okay, and switch to another window type. So we had a window 2 meters by 2 meters. Let's see if we have something. Well, the closest is this one. If you change to this, you are basically substituting all the windows with this new family here. And so everything is now set up properly. If we go back to the 3D view, you also see the windows. Okay, so it's very easy. Once you have defined things in Grasshopper, you can also adjust the final step in Revit if you want. But I do look forward for this family recognition, family understanding from Revit side to be fixed by geometry, because it's, well, it eliminates one step in this process. So once you are capable of importing the right family, for example, you can also rely on Revit automatic processes, like, for example, these of having all the details already created in your viewports. Okay, so especially if you are working with some extremely nice family, you will have even more details than this. This is quite simple. You only have some lines and so on. This family doesn't take into account, for example, to have some finishes here in the inside of this void in the wall. But it depends on the family that you are using. You can also load additional families which are more detailed than this one. Another thing that I wanted to show you is that if we are, for example, in level 1, this is something that I already was already telling you yesterday. The levels or floor plans normally have a view template associated. If we are in a floor plan and we browse into the properties of this viewport, and we go into the identity data, you will find view template. Okay, so by default there is no template associated, but this is an architectural template, by the way. Okay, so even if you see none, by default you have some architectural visualization style. Okay, but it's not a style because it is a complex set of parameters that it's basically associated to a view template. So if you click here, you can switch to architectural template, and this is the set of parameters that are automatically tweaked by selecting this template. And if you do this and apply, you see that the only thing that disappears is the shaded mode. So the default view template is already an architectural template. But if you switch, for example, to a structural framing plan, you see that you are seeing exactly the elements that we have created in Grasshopper as regards the beams, for example, beams and columns, of course. So this is a standard structural view. Well, actually, it's not exactly like that, because you see the wall are basically dashed. These elements should have the preference with respect to the walls. Okay, so it should be exactly visible. This is something that you can tweak inside the parameter here in case you want a structural viewport, a structural floor plan. But it's nice to see, for example, that the girder are represented with a bold line, the joists are represented with a thinner line, so you have an idea also of the order of importance from the structural point of view of the elements that you have created in Grasshopper. And the reason why you see this at level 1 is because remember that structurally speaking, the structure that is being represented at level 1 is the structure that holds or creates basically the floor of level 1, not the ceiling. Okay, so we are still looking downward in this case. Maybe, yeah, we are still looking down. Okay. So it's pretty nice to have this kind of also of automatic representation deriving from Grasshopper to Revit export process. Okay, so everything is perfectly smooth. Um, in this case, eventually, what I would do something like this. Rename this to level 1 structural, for example. Oh, my bad. No, I don't want to rename the level. So what I did here, just so that you can see it. So level 1 structural. I don't want to rename the corresponding level and views. Okay, because if I do this, I will also have level 1 structural like visible as a level in all the elevation view, section view, and so on. So I don't want this. I just want a particular floor plan here. So I don't want to update the names. So if I go back, for example, to the section 1, I still see level 1. Okay, let's go back to level 1 structural. Let's, for example, duplicate this view, not as a dependent view, not with detailing. I'm not going to go through this, but I'm just creating a duplicated, a copy of this structural view. I'm going to take this view, change the template to architectural plan, go back to the standard architectural visualization, and rename this as level 1, which is probably the default view that we want to have in our project browser. Okay, and so now we have 2 different floor plans for level 1. One is architectural and one is structural. And the reason why I did this is because in this case I can take these 2 different views and place them together in a single sheet, for example, for presentation purposes. Okay, so it's very nice to have this kind of automation in Revit that derives from Grasshopper characteristics that we defined parametrically. Okay, so that this is probably the most interesting feature that that we can have, despite the architectural one, which is already pretty nice to have as a workflow. But you can see that also from the structural point of view, everything is perfectly working. And this is also valid also for other things. For example, if I take section 1 and duplicate view and eventually rename this to section 1 structural and change the view template of this to structural framing elevation, you now see that we have the same behavior, but from the elevation point of view. This is not as representative as the floor plans, of course, but you can see that the template are you can apply them to all the viewports that you have in your project. Okay, this makes less sense, and in fact, I'm going to delete this viewport. But anyway, it's important to double check that everything works perfectly. And you can also create this kind of thing here. Once you have defined everything properly in Grasshopper, it's very nice to work in Revit, because, for example, let's say that I want to define a section box, which is like a cross section, automatic cross section, but it's a three-dimensional cross section, as you can see. So this box is going to define the portion of our building that is going to remain visible. So it's like clipping planes in Rhino. Okay. So if I, for example, go into the top viewport and say I want to concentrate on the stairs, I just grab these sides and isolate the stairs from the rest of the building. Remember, we are in a three-dimensional viewport, so if you do something like this, you see that we are only seeing the actual three-dimensional representation of our stair with all the details. And the details depend, by the way, on how much level of details you want to represent. If you want to work in shaded mode or wireframe mode or hidden line or realistic mode as well, which has the rendered material, which is not like as fascinating as you might think, for example, because we are still working with default Revit materials. Something changes when you perform a ray trace render. In this case, ray trace render is always a little better than realistic view. As you can see, material look a little more decent. Also, the lighting effects, it's a little better. But there are some tweakings eventually that you can do in visualization if you want to create some nice representation of the project. But it's very nice to take a look at these details that we have created in Grasshopper from the Revit point of view. Okay, so you see primary beams, columns, secondary beams, stairs, and railings, and so on. Everything is working properly, as well as the floors. So yes, that's pretty it. And what I wanted to show you is this. Let's go back and not use a section box. So the section box is not taken into account, but if you want, you can reactivate it and edit it once again. But nevertheless, it's not that important. So let's get rid of this and let's go back to Rhino. So one thing that we know that we can easily achieve, because we changed things in our original definition, we are going to tweak two things. First of all, I'm going to define the wall in a more proper way. And secondly, I'm going to change the position and orientation of these stairs. Okay. So first of all, let's grab this. Well, let's get rid of this group here. Let's move everything here to the left, and let's substitute here the layers. So starting from the outside, we must define the Revit material. We already have, well, let's stick to a real Revit wall. So let's take this wall here. Let's select all instances in entire project, and let's go with an exterior. Well, not this one because it is pretty complex. It has several layers. I just want to focus on material. So let me take a simpler template or a simple family. So let's go into the edit type for this. We should have 3 or, well, no, yeah, it's just a zoom factor. But nevertheless, let's concentrate on this material. Okay, so brick common. I want to use bricks for the exterior finish. Okay, 9 centimeters. So let's go here. Let's also copy this, paste brick common. So this is going to be the material name. Let's also, yeah, do something like this. Let's name this material like this. The class is going to be masonry. Description is not relevant, but anyway, remember that when you use a Revit family, Revit material, everything will be set inside Revit. So you can also avoid wasting too much time at the material level. You just give the right name and that's it. So this is going to be the exterior finish. So function is going to be finish one. Let's also move all of these things down a little to make room for our things. So it's going to be 0.09. Well, actually, let's use a slider with some more capabilities. So 0.15, and then set it to 0.09. So this is going to be the thickness. Everything's already set. Function we already set to finish. Is it core? Let's take a toggle. No, this is going to be outside from the core. Is it structural? No. Or maybe it depends. No, it's metal inside. I imagine. So 15 metal stud layer. So it's metal structure inside metal framing eventually, and then you have this kind of finishes. Well, let's try to because it is actually not possible um, to create a wall by defining the family. Maybe, or maybe we can give it a try and see what happens. But no, let's not waste other time. So let's complete this in a safe way. So this is going to be the first layer, and then I'm going to let's move this here, and then I'm going to create the let's keep thermal air membrane layer. Let's place a substrate, plywood sheeting. It's okay, whatever. With 2 centimeters. So what I'm going to do, I'm going to copy paste these. This is going to be plywood sheeting. This is going to be 0.02. Not core, not structural. Okay, and then we have this metal stud layer. Let's call it like this, 15 centimeters. So this is going to be a metal stud layer. Um, Class of this is going to be wood. So remember, just for keeping things consistent, just pay attention to these details. Okay, so masonry and wood, and this is going to be something metal-ish. So metal, and then we need oh, and this was 15 centimeters. Okay, so let's grab this material. Thickness 0.15, sorry, not the function, the thickness. And let's grab these two here, and let's say it's not core and it's not structural. Well, actually, yes, this is structural and this is core. Exactly. And finally, inner finish without membrane, just gypsum wall board with, let's say 1 centimeter. Okay, so let's create this. This is going to be gypsum wall board 1. See that one? If you don't put that one in the name of this material, Revit would not recognize the material itself. So you must pay attention to this. Let's say 1 centimeter for this. So thickness, and then these two buttons here. This is not going to be core, and it's not going to be structural. And the class of this is going to be something like paint coating or something like that. Yes, I think it's the closest things that we have here. But anyway, so we have the material already set. We have the one that is part of the core. And so we can get rid of these and define the layers using this. Now, I'm not giving the same family name as for this, which is exterior dash brick on metal stud. I'm just leaving in default. Okay. Remember that these walls are actually recognized by object ID during the import process. Okay. So so basically, as I didn't change the path or perimeter, I just changed the wall type. The object ID should be still the same. Okay, so this is the purpose of this part of this session. And last thing, I'm going to go into the stair definition. I'm going to take the stair axis, which is this line, and I'm going to place the stair somewhere, set one line, and I'm going to place it like, say, here at the center of this. Let's see if everything updates. Okay, everything. Let's hit F5 because you see that the shaft is still present, but it's here. Remember that as the void is created after the floors, then you must refresh the definition in order for the shaft to disappear from here and appear here. Okay? And now let's reorient the secondary beams because they are oriented in the wrong direction as regards this stair. Okay, so let's go into our secondary beam definition, and let's take this point here, at least this one, and let's move it, for example, somewhere like here. So you see that now the secondary beams are already present, but not inside the volume of our stair. Now, take a look at this. This is something that is not correct, of course, but because my script is actually deriving the presence of a secondary beam according to the position of the center point of the secondary beam with respect to the area, the footprint of the stair, then the center point of the midpoint of this beam is actually falling inside the footprint of the stair. Therefore, this beam is going to be deleted. This is not correct. Okay, so how can we correct this thing? For example, we can eliminate secondary beams only if they fall inside the shaft and not inside the footprint of the stair. Okay, so where is this thing happening? This is happening like here, and we are using the footprint of the stair. As you can see, you see the green area is this one, but instead of using this, I can also take the shaft where it's defined, which is basically this intersection here. You see that now we are reaching only up to this, which is the primary beam, by the way. And so if I take this region, which is a polyline curve, closed polyline curve, and plug this inside the point in curve, we should see this thing reappearing. Yeah, exactly. So perfect. So now we can also get rid of this loft and etc., because everything is working smoothly. So let's also hide this point. So I think everything is back to normal. Let's double check here. You see the rating is already adjusted to the new position. The beams are already also adjusted, and everything is working pretty good. And so once we have here, once again, just for like sake of avoiding any possible variable or accident, let's hit F5 once again. So refresh the script, the solution. Let me save things because you never know when Grasshopper is going to crash. And let's re-export this. I will overwrite the existing version. Remember that tomorrow we will take a look at Rhino inside Revit as well, and you will see that this will be not necessary to overwrite IOC files and so on. You just update or refresh things, and everything gets synchronized between Rhino and Revit. So now we have to do this manually. Okay, so if we go back here, let's see the pros and cons that we have in this moment. So I'm going to concentrate, for example, on the level 1, and I'm going to go into Geometry G, import IFC, select the same IFC, and here you see that you have here at the bottom update existing family symbols. And also there is another checkbox, which is disable existing element update, replace, removal. Now, we don't want to do this because we have changed the position of the stair and the orientation of the beams and so on. So we don't want to disable this, but we are updating existing family symbols, and we are updating basically the object also by the object ID. So when we proceed with this, let's give some seconds, as you know. And here we are. This is the error for the door family. We have the new stair here. Let's wait for this to update. And you see that now we have this problem here with this existing shaft. This is not being updated. You still have this present, but this is a minor problem because the shaft is just one void. You can select it and delete it. So there is absolutely no problem with that. Grid lines and everything has been re-imported. Okay, so this means, for example, if we go back to the south viewport, um, you see that now we have this. Oh, I think my bad. I think in that case it's inner to out, in to out for the walls. You see the bricks are in the inside of the walls. But anyway, we can simply fix this in Grasshopper by changing or reversing the list of connected material layers. But everything is respected. You see the tweaks that we did, for example, by aligning the levels and so on, has been maintained because the only thing that gets changed basically is the level height. Remember, from the IFC import interface, what is adjusted is where is it? Existing Revit level elevation. This is the only thing that gets updated. So these levels already exist. If you change the elevation of a level in Grasshopper, then it will be updated. Okay, but this is not the case. So everything regarding the visual aspect of these grid lines and levels has been kept. Okay. If we go into, of course, if you go into the cross section, you no longer see the stairs right now, but you see the bricks. This is quite stupid because it should be like the opposite from this, but this depends on in which order. So instead of plugging here from out from outside to the inside of the wall, it's the contrary. So it's from the inside towards the outside. But nevertheless, beside this, you can simply go into here, for example, and reverse this. So this is actually inverting the orientation, the order of this data inside this list. Okay, and that this is enough for creating the proper sequence of layers inside the wall. But anyway, the more important thing is that the structure, well, everything is set already with the proper physical properties, and also the structure is corresponding to the core and non-core conditions. Okay. And as regards our 3D view, which is the last thing that we are going to see, let's go into top. Let's visualize the section box. Let's focus once again on the stair, probably because it's the more interesting part in this building. It's the only interesting thing in this building, actually. And so what I want to double check is that the beams are oriented properly. Yes, they are. So everything is has been, let's say, updated with the last import. So we have also columns are being sectioned, and the IP beams as well. So yeah, that's pretty it.